I'm going to show in this video how to solve a particular type of physics problem which is commonly seen in questions on optics and waves and wavefronts, wave drawings. So let's say we're given a problem like this. We're shown this diagram, and this diagram indicates it has a black line which is an interface between two different media. And we'll call one of these medium A and the other will be medium B. And so some wave is passing from medium A into B, and when it does, it will be refracted. Okay. So the blue lines that were shown are wavefronts. The black line is the interface. Now let's say we're told something like the velocity in medium B is, what should it be? Let's have the velocity in medium B will be faster than the velocity in medium A. So the problem won't be this straightforward. It's not going to say the velocity in B is bigger than the velocity in A. Instead, what the problem says is the wave speeds up when it enters the new medium. And we have to infer this. Now, if we know that, then we also know lambda b, the wavelength, is bigger in the new medium. And we know the angle is bigger in the new medium. In fact, everything is bigger in the new medium except for the index of refraction. Okay? So if you know any one of these facts, then you know all of those facts. Right? Any one of these four things implies the other three. So if we're told that this wave speeds up, then we know everything else on this list. Okay, so now we're ready to start solving the problem. Now, normally in these questions, you'll have to solve using Snell's law. You'll have to solve for some quantities. I'm not going to do that. Instead, I'm going to show how to draw the new refracted rays, wavefronts, in medium B. Okay, so we only have half of the wavefronts. Only those wavefronts in medium A are shown. Our task is to draw in wavefronts over on this side, right? What happens? Do they go straight across? Do they bend away like that? Do they bend down this way? Just this way? What happens? So that's what we're going to figure out how to do here in this video. The first step, very, very first step, draw the incident ray, right? And you always draw the incident ray so that it intersects right here. It ends right there. So the incident ray is always perpendicular to these wavefronts. Whoops. It's perpendicular to these wavefronts. That means it looks something like this. Right? And I know it has to end here, so I'm going to draw from there. And it's going this way. Right? Step 1, draw the incident ray. That's done. Step 2, draw the normal. That's easy. It's this line. Okay. Step 3, draw the refracted ray. Right? And this is where our information over here becomes important. The refracted ray is going to have to be, what, does it get kicked out away from the normal, or does it get brought in closer to the normal? Well, the way you find out is by looking at the thetas. The new angle is bigger than the old angle. So here's the old angle, and the new angle is going to be bigger, right? A bigger angle from normal. The other way you can think about this is that n measures how tightly that medium pulls the ray in toward the normal. So the bigger the n, the more it gets brought in toward the normal. The smaller the n, the farther out from the normal it goes. So if NB is bigger than NA, then this thing is going to get kicked out away from the normal. NB is not as good, this second medium, B, is not as good as the first medium at holding the ray close to the normal. That's kind of how you can think of this. Alright, so this is all a long-winded way of saying draw the refracted ray. And we know it's like this, because the refracted ray gets kicked out away from the normal, deflected away from the normal. And look, now theta A is smaller than theta B, right? Or B is bigger than A. That's what this says. Okay, that was step 3. Step 1, draw the incident ray. Step 2, draw the normal. Step 3, draw the refracted ray, which is this. Step 4, the last step, draw the new wavefronts in medium B. And you always start, again, we're always using this as our reference point. So just draw a line extending from here, which is perpendicular to this new ray. It looks like this, right? It's perpendicular. And then you draw parallel lines connecting to the other rays, the other wavefronts. And that's how you solve these problems. Step 1, you draw this, the incident ray. Sometimes it'll be given in the picture, and you always draw it. You'll draw this ray so that it intersects right here with the middle of these three wavefronts, intersects right at the center wavefront. So it comes in, that's step 1. Step 2, draw the normal. Step 3, draw the refracted ray. Step 4, draw perpendicular wavefronts. And always start here with the middle wavefront extending out from this central point. And that's how you solve these problems. Notice, if instead, if we had NB being bigger than NA, so if we had a different problem and this were not true, then they wouldn't look like what I've shown here. Right? If NB was bigger, if it were bigger, then the new ray would kind of come kicking out. It would get kicked closer in toward the normal like this. And then we would have totally different looking wavefronts like that. So they would get refracted the other way. So in these problems, you can use the same method that I've shown here to always draw in correctly the new wavefronts like this.